which we can't have together. I was wondering if we should have
For sure, I'm interested in looking at the impact of using this in various coding schemes.
Yes.
I used to develop the coding scheme, which is Tetris, which is going to be running and we look at the impact of using such mechanisms to receive from wire or wireless link within the internet. So one of the techniques we saw some discrepancies.
Bon, alors, on va tell you that, Kanchana. Nico.
Hier soir, on dit IETF. Vous voyez les odeurs par
So I can exchange.
Alors, il y avait un film occulte pour des années.
It should be soon because I just get out the result now, you know, so I have some curves and
Et en fait, quand tu arrivais au film, il donnait une espèce de scratch et tu pouvais gratter. Et il y avait des odeurs qui passaient, évidemment, c'était horrible, ça sentait hyper mauvais. Et ce qu'on se disait, c'est que tu t'imagines si tu envoies ces odeurs mélangées par Internet et qu'il y a un bug et que tu es supposé envoyer de la cannelle, et en fait, ce qui sort, c'est un truc absolument des skunks, c'est des en fait. On a tellement rigolé. Mais c'était pas drôle. Et merci de prendre les notes.
Non, mais on va faire sur les terpènes.
Ah, vous allez faire à 3. Et c'est beau.
Enfin, c'est plus facile.
La communication est parfaite. Qu'est-ce qu'on a là, nous? Ah, on est là. Comment t'as fait pour faire ça? J'ai essayé de me loguer sur mon chat.
the FCRD, the Français Coding Research.
It's true, but we're missing Muriel and a few other people.
Yeah, but that would be the Espanol coding.
Yeah, but she's also French, so. Toute la gang de l'équipe sont là, y compris celle que je vois, c'est qui. Tous les gens de Loop sont là. So you hear us well? Okay. No problem. Yeah, I have the impression this thing is aggressing me. Ah oui. Une c'est assez? J'ai préparé 2.
I suggest we start.
Commencer?
Vas-y, comme d'habitude.
Okay. So welcome to the Network Coding Research Group, or as Dave Oren just said, the French Coding Research Group. This is, I think, the continuation of a number of the work that we've been doing for a while, but I think there's always new things. I think I would also welcome Raymond, who is usually online and is finally here with us. So welcome to the group. And yes, we have a number of interesting presentations. We're also very happy to have today the people from Loops who are looking at similar things, but more from the IETF point of view. So again, we're not the IETF, we're the IRTF. So our goal is to foster research and mostly in network and application layer coding to improve network performance. And I have a presentation a bit later. It's not just the networks that we know like now, but also the future of the networks where you start having computing elements everywhere. So we want to look at coding and coding libraries, protocols, and a lot of real world use cases. And I think this is where there's a lot of cool stuff happening also in the work in progress. Well, okay, so this is no, I pressed the wrong button. Thank you. Yeah, this would work better. So this is the new note well for the IRTF. If you haven't seen it, it restates a lot of things that we already know, but it talks about in the more specific IRTF world, and obviously there's all the issues still of, am I doing something wrong? Oh, thank you.
Yes, thank you.
You know, technology is difficult. C'est démarqué en plus? Oh, wow, okay. So it's very much more in the IRTF point of view. It means that, you know, we still have you still have to disclose any IPR and patents. New part of it is that we also have to be nice to one another, as the IETF wants to more and more foster an environment where people feel safe to express opinions. And this one states explicitly the goal of the IRTF, which is not to do standardization, but is very much to foster research and foster communities of research along the topics that we're talking about, in this case, coding and applications. And I think that makes it very important to see also how IRTF and IETF can work together so that the research is done here, and then eventually we can actually you know, send it to the IETF when there's something that needs standardization.
Yep. So this is about the administrative stuff. There's no big change. Just to remind you that you can have a look at the GitHub repository where we store all the presentations, all the minutes, everything that concerns this working group, research group, sorry, as well as the Swift codec implementation. So everything is there. So do not hesitate. There is also, of course, the data tracker. This is the agenda. So we have almost full agenda today, maybe with 10 minutes of spare time at the end. We will see. Does anybody want to change or add something, talk about something that was not in the list in this agenda? No, it's okay for everybody? Okay, so we'll go through it. First of all, a few news about current internet drafts and some news also on related internet drafts. So concerning the group documents, except the presentation we'll have later on, we have two topics, two sets of internet drafts that will not be presented today. The first one is about network coding for CCN, NDN environments with requirements and challenges. So Dave, you made a comment some time ago. It was in IETF 104, so in March this year. The document, the idea was to discuss document within the ICNRG. This is what we said at that time. So what's the situation? I have no...
Situation is you've put me on the spot in public. I've gotten no feedback from anybody in the RG on the document. Since then, I'll bug everybody again.
Okay, so when you feel that we can continue with NWCRG last call, then tell us. Tell us what you...
Why don't I give them a month and then we'll move it forward no matter what happens. How's that?
Okay.
Well, I have to confirm that with my co-chairs, but I think
Yeah,
it's
of course,
fairly
of course,
reasonable.
of course. Okay, thank
By the
you.
way, this mic is off. So if there's anybody, is this mic on? Oh yeah,
Yeah,
okay, I want to make
it
sure the
should-
people on the me too, can hear it. Thanks.
Okay, thank you for the status. The other one is about this, those two documents, RNC documents. Unfortunately, nobody from the authors was able to come to this or attend remotely this meeting. But the situation is the following. Janusz told us that there was an update on the RNC symbol representation document, small update fixing a few things, nothing very essential. There is also another document that expired, unfortunately. At the moment, they don't have any clear view on what to do next. So the situation is a little bit ambiguous. He asked us, chairs, Janusz asked us to ask to the group everybody to have a look and to provide feedbacks. And we will also have to decide together what we want to do with these two documents. Accept them as working a research group item or not. So that's an open question to everybody. So if you have an opinion, you are invited to express yourself on the list, on the mic, as you want. We would like to take a decision on those documents rapidly. There was a desire concerning the chairs to have RNC documentation, so it makes sense, but okay. Does anybody want to discuss this? No?
Well, I would actually really support what Vincent has said, and I think it's because it goes to the notes, so please put it there. I think it's extremely important that we have a document on RLNC, and I would put also the people of Tetris on the line here. I think since one of them is here, I'm looking at him now, and I think one of the goals of this group at the beginning was to have a set of documentation on existing FEC solutions or network coding solutions. And because, again, we have in the room the people from Loops who are actually looking for directions when they start doing some FEC beyond the stuff that is already existing on open source and everything. So I think it would be extremely important to continue in this way of having a set of documents. I think we're having very soon the RFCs from Vincent on the Swift codec, but I think the other ones, RLNC and Tetris, I would really, really like to see them with my chair hat. I'm actually so tired. My chair hat on. I would really, really like to see those happening.
Just about the Tetris draft, Jonathan did some correction. I think there is nothing more to add inside. So I will have a chat with my colleagues when I will be back from Singapore, but we don't see anything else to add inside. So
we could adopt it as a document and actually move on. That would be fantastic.
Feel free to discuss or to comment or to criticism.
Well, I think if you can post a new version, I think we would really be really happy to be able to put it as a group document and move on.
Yes, there is an updated one that is not published yet because we still are discussing on it, but if it's of interest for the group, we will publish it again.
Well, if you look at the charter, it was part of the charter to have a set of
I know.
documentation.
I know. I will speak with Jonathan at when I'm back.
Thank you. And we will make sure to connect to the RLNC people. But Yanis, I think, was very open to it. It's just that he has a family emergency.
Yes, thank you. A few words about the three related internet drafts. So about FakeFrame, RLC, and TNMT32. So those three documents are almost done in the sense that the RLC and TNMT32 PRNG have been not yet really published, but almost published as RFC. We already have the numbers, 8681 and 8682 for those two documents. And now we are just waiting for a final approval by Magnus, our area director, on the FakeFrame extension to sliding window codes. Just a matter of rewarding a few here and there on the documents. It's not a big deal, but we are waiting for his approval. And then I guess that in the coming days, it should be published. The three of them will be published together as RFC. So we are very, very close to the end now. So for the future, well, we'll talk about it at the end.
Yeah, we could talk about it.
Yeah. Okay, so let's move to the first to the following presentation by myself.
It's à combien de temps?
5 minutes. Yes.
Okay.
Yes, it's working. No.
Press the other full screen thing as well.
Yay.
Yes. There is a right order for that. Okay, so this is just a quick feedback from the hackathon on Saturday and Sunday. So I remind you the goal of this hackathon. This is to develop an open source reference codec, free codec for sliding window codes, and also to challenge document on the API for such a codec. So we were 3 people at that time for this hackathon, myself, Umeima, and Cedric. I'm very happy that in between this hackathon and the previous one, Cedric and Umeima managed to work a lot on this project, and we are approaching, not the end, but we are approaching a situation where things will start working very well. So what has been done? So the encoder, let's say it's almost done. The decoder, and that's the great thing because this is the complex part, starts working. So we managed to do decoding and to rebuild source packets and check that this source packet is indeed okay. We also have this C demonstration application that's almost done, and the Python work of wrapper and demos on top of this wrapper that are almost done. So we are approaching the end, even if there's still work to be done. We also managed to, we also found an issue in the API, stupid thing. And there are 4 points that remain open in this document, and in particular, I would like to say a few words about the ESI, the encoding symbol ID. It's not something very trivial because currently the way it's implemented is just type def. It's type def to an unsigned ENT, 42 bits, and that's all. But if you look at some of the documents we are working on, in particular this RLC for quick documents, you will see that this encoding symbol ID is represented as a variable integer in the sense of quick, so meaning that it can be a small or larger integer. So that's something non-trivial to do in order to map this variable size into the API in a way that it can be used in different contexts. So that's something we'll have to fix in the next hackathon, hopefully. So the next step now is for next time. I said Montreal, but that's a mistake. It's Vancouver. So in our IETF 107 at Vancouver, we'll have our 5th hackathon and do some kind of improvement of the code, cleaning and things like that. Documentation also is something that could be very useful, explaining much better how to do encoding, decoding, how to write an application on top of those encoders and decoders. So. And once this will be done, then we will be able to move to the next step, which will consist in having this RLNC like codec being implemented. It's just a matter of changing a few things inside the codec, but it seems simple. Say it like that. It's always a bit more tricky when you go into the source code when you want to actually implement it. But that's something that will be our next goal once this RLC-like codec will be done. I'm done for this quick hackathon. Once again, I would really like to thank Umeima because thanks to you, we made a lot of progress on this project. Thank you very much. And also Cedric. Comments? Yeah. Do you want to say something? Okay.
Any questions, comments? For those of you who have not participated in the hackathons yet, I'm actually also running another one in parallel this year. We didn't manage to get the same table, but I think it's becoming more and more a really nice way of learning what the other groups in both the IETF and the IRTF are doing, because for 2 days, we're actually co-located, as when we're here, we're so much distributed in different places. So I would really, if you can arrive early on the Saturday, I would really recommend that you show up, even if you we don't want to hack, just come and hang out.
Yeah, and there's also this presentation on Sunday afternoon where you will get a feeling of what's going on during the hackathon. So everybody will present during a few minutes what they managed to do, the goal of the project. And so it's very interesting to have a global view, overview of what's going on in IETF and IRTF as well.
Thank you. Next.
Moi, je fais le time. Next, c'est qui? Ah, c'est Nicolas. Combien de minutes? Non, c'est beau. C'était beau. Oh, regarde. C'était bon. Voilà.
Perfect. Okay, so. Okay, so let's go. Let's go.
Yeah.
Okay, so hello everyone. I'm sorry because that's the very worst part of the day for me. I've been sleeping every early afternoon this week, so I hope you're not sleeping. I hope I'm not. This is an update for the network coding for satellite systems document. That basically I will go through what happened, and for those who are not familiar with what is the scope of the document, the idea is to identify scenarios where including network coding at higher layer than the physical and layer ones in satellite systems makes sense and is an opportunity for more network coding deployed in general. So we were in research group last call in April. We have had a second one in the 15th of October, and we received Lloyd Wood's comment on the 26th. So I have here some slides on explaining how we dealt with every single comment. They are also available on the GitHub repository of the research group, where we made an issue for every comment we received. So I can go through them. I don't know, I have time, but okay. Because he's not here anyway, so, but I will go through it anyway, okay. In case. Okay, basically that was a comment on the fact that it's not really clear whether we are speaking about link layer and physical layer or not. We tried to clarify that lots of times. Apparently it was not enough. So we really skipped lots of things from the introduction to really narrow directly down to what the actual problem and the document is tackling. So that is one of the main changes we've done. Another one that is more satellite, speaking to a satellite guy on do we need to specify what a spec frame is as opposed to a BB frame. And in the document, we say that this is a satellite discussion, so we point to the DVB standard documents, and you just don't need here to know what's below the access layer. So
just one comment, the fake frame, this fake frame is not the one I'm talking about. So it's a bit confusing even for myself.
Yeah, that's DVBSD wording, so that's, I'm sorry for that, I didn't realize. Didn't make a link. That is somehow editorial as well, or more change figures to make things clearer, so we have done that as well. And that's a comment related to also the problem on ACM. ACM is a mechanism we have as a link layer in satellite systems to actually have reliable transmissions that enable us seeing clouds coming and adapt the coding rate. And what we say in the document is that these mechanisms do not go as quickly as they should for mobile users, or when we go through higher bands, such as the QV bands. So we basically here tried to make that way clearer in the document that all these link layer stuff are out of the scope, and I hope it's better. But then we thought we were over, but then we received also comments from Vincent. So basically there was another error on the FEC in the glossary. There was wording issues in the traduction. In the end, figure one was, so this has been done this week, earlier this week, because we just sat down with Vincent and took all of the issues he had one by one and worked directly on the GitHub of the document. So basically, when something was confused, in general, when something was confusing, we removed it. Try to have a very shorter document to go straight to the point of what is in the scope of the document and what is not. We tried to have a better wording. We are not native speakers, so if anyone wants to review our English, you're welcome. We removed the figure that one that was confusing.
Also, that's another problem we have when you mix words, that a payload for satellite is actually the thing that is flying and not the payload of the packet. So that can lead to some confusion. It's the same issue such as we had with the fake frame. So we just remove that. We just speak about satellites and not. That is the kind of editorial things we've been doing. And we have tried to put some details on the multipath use case. And we have rewritten the section of modulation encoding and mobile and QV bands because that was not clear. So we think that with this update, the document is ready for another round of last call. And so if you have any question, we are here. If you want to review the document, thank you very much. And that's it.
Yes, so just to make it clear, this document is hopefully close to the end. It was a research group items for some time. We went through already 2 last calls, and now there are still perhaps some problems, but they are more on the editorial side, English improvement, things like that. Hopefully it will be fixed rapidly. So the idea is to ask for volunteers to review this document if feasible. Marie-José and myself will read it again as it is now and trying to fix the last few items. But hopefully it will be soon moved to the next step. And I am the document shepherd, so I will take care of this.
Thank you.
Okay, thank you. Okay. So we now have a presentation from Raymond. It is great that you managed to come this time. We are very pleased of that, as we said before. Just to remind you, there was a work in progress on this topic on batch codes, and Raymond made several presentations of those codes and also the use case where those codes are going to be deployed and so on. So this is an update of the situation. There is also an internet draft that is associated to this work, and we would also like to discuss about it at the end. So thank you. I give you the floor.
Okay, bonjour everybody, and thank you, Marie-José and also Vincent. Okay, I'm from the Institute of Network of Chinese University of Hong Kong, and I also have a hat because I'm now running a startup company called NHOP Technologies. Okay, so I think I don't have to say too much about smart lampposts, but I just say something about the background. Now, the thing is that there are a lot of equipments on the smart lampposts, and they must be connected to the internet backbone. And possible technologies are optical fiber, cellular, and what I'm going to talk about is BATS, which is a kind of like an efficient implementation of random linear network coding. Okay, so for optical fiber, we know that it has got very high data rate and highly reliable, unless you accidentally take up the fiber. However, it has high installation costs. It's a very long setup time. For example, I was told that in many cities, if you want to get all the licenses for digging up the road, it may take 2 to 3 years, which is too long a time to wait for many applications. And so realistically, only a very small number of lampposts in the system can be directly connected to optical fiber. Now, the rest, you still need to find some way to connect them to the internet. So how about we use 4G or upcoming 5G, okay? So it's very simple. You just install a 4G card at each lamppost, converting each one into kind of like a cell phone. The pros are it's easy to deploy and relatively inexpensive, but the cons are it has a very high recurring cost because you upload data 24 hours a day, okay, 7 days a week, and you need to pay the monthly service fee. Okay, if you're talking about a city with 10,000 lampposts, and you have a pretty huge monthly fee to pay, and the government usually do not favor this kind of solution. And for 4G, another problem is that bandwidth drastically drops during rush hours. Hopefully it will not be the case for 5G. Now, so what we are introducing is a multi-hop solution called BATS. So now in this particular illustration, we have on the left-hand side a lamppost which has direct connection to an optical fiber. And what we do is that we connect the rest of the lampposts on the same street using a wireless multi-hop network. Okay, so why do we want to talk about BATS? The problem here is that multi-hop is a long-standing problem in wireless communications for the reason that for each hop you lose packets, and if you regard packets as being a commodity, then there's no way that you can prevent packets from losing along the way, and the throughput drops exponentially fast with the number of hops. Okay, now I talked to some people in industry, and sometimes they call this the multi-hop curse. And BATS, as I mentioned, is an efficient implementation of random linear network coding. And with this technology, transmission can sustain tens or even hundreds of hops without relying on link-by-link retransmission, which actually is very bad for video transmission, as some of you may know. Okay. Now, the idea is that we employ recoding at the intermediate nodes, and with BATS, a very long multi-hop network can be realized. Okay, so this is a monograph that was published by Shenghao Yang and myself. He's the co-inventor of BATS code that we first proposed in 2011. And so here's a performance comparison between BATS and, in this example, I just put down TCP/IP, but it could be any store and forward based technology, including file and code, for example. So in this case, we assume that the packet loss on each link without retransmission is equal to 20%, so that after one hop, you got only 0.8. Okay, and if you use store and forward along the way, then every hop you multiply by 0.8, and the throughput drops exponentially fast. Whereas with random linear network coding, ideally, the throughput won't change with the number of hops, okay? But this is ideal, and which is an asymptotic result. Now with BATS, which is kind of like a good approximation of the asymptotic implementation of random linear network coding, except that it's highly efficient and can be implemented on most platforms. We see that there's a drop in performance, but the drop is very slow. Okay, so after 50 hops, you still get about 0.7, and the drop actually becomes slower and slower. And in this plot, we see that after 1,000 hops, you still get about 0.66 of the original throughput. Okay. Okay, so these are some technical features of BATS. It's got high throughput, low latency. As we know, for random linear network coding, it is basically a pipelining operation, so you don't wait for any lost packets or that kind of thing. And it's got a low coding complexity and low storage requirements. The last two features are regarding the efficiency of implementation. And now, last, I would like to talk about the real deployment of BATS in the Hong Kong Smart Lamppost project. The plan was to install 400 smart lampposts starting last summer. Okay, this is the scope of the pilot project, and then followed by several 10,000 lampposts. And our startup company has been commissioned to deploy BATS in 36 out of the first 50 smart lampposts. And so this is the first smart lamppost in the system that was erected in the city. And so our project participated in the 2019 exhibition of inventions of Geneva, and we were very honored to receive a gold medal with congratulations of the jury. And so this picture shows the design of the smart lamppost. It is hollow in the middle, so that all the IPCs and other devices can be concealed inside the lamppost, which is very important for Hong Kong because you may know that in Hong Kong there are a lot of hurricanes, and this is actually a very good design for the local situation. And there's some there are few gadgets here which are called donuts, and these are small containers that actually contains the antennas for BATS. Okay? So this particular box here is what we call a BATS box. It is an industrial PC. Okay? And the best box was actually co-developed with Advantech. As some of you may know, Advantech is one of the leading IPC vendors from Taiwan. And the current status is that we have already successfully deployed at 2 streets. Unfortunately, as some of you may know, there's a big turmoil in Hong Kong, and on August 24th, there was a protest in which the smart lampposts at one of the streets were heavily vandalized. That's very unfortunate. And the deployment was almost done at another street. Now, the reason is that the general public has concern about the installation of video cameras on the lamppost due to possible infringement of privacy. And to respond to this, the government has formed a special committee to review the smart lamppost applications. And so this is something we need to be mindful about for this kind of applications. And so one possible recommendation from the committee, it could be to replace the cameras by radars or lidars, which is less sensitive because the radars and lidars cannot really do face recognition, okay, and also could not recognize a license plate. Okay, so there's one thing I would like to mention, which I didn't realize before, is that the BAS actually has got a very close connection with fog computing. Because BAS is inherently a fog computing application for the reason that the computation must be done at edge. Okay, for most other applications, you can do it at the cloud, except that the performance may be degraded. But for BAS, it must be done at edge. So BAS is actually inherently a fog edge computing application. So we plan to install 20 fog node based smart lampposts on our university campus, with BAS being provided as a service by the fog node. And this is meant to be a prototype for the next generation smart lamppost. And there's some further opportunities that we've been exploring. We talked to some departments in the government. They are very interested in installing smart lampposts in country parks, which are largely not covered by cellular networks. And this poses some threats to the hikers. Okay, so and also that we learned that many cities in Southeast Asia are interested in having some kind of pilot smart lamppost projects. So as mentioned by Vincent, we have submitted an internet draft, and this is the list of patents that we have obtained so far. Okay, thank you for your attention.
Okay, thank you. Comments from the room? Yeah.
Yes, Emmanuel.
Thank you. Thank you for our presentation. Just want to come back to slide 8, please. Yes, this one. I have good eyes. I was not sure. So we all know that TCP is collapsing in such a use case. So the things you are showing here is that you encapsulate TCP inside your bytes coding.
No, we don't use TCP. We use UDP.
It's a UDP.
Yes.
So you compare TCP standard with a UDP flows, which is bytes coded.
Yes, correct.
Okay. So there is no fairness.
No feedback.
No feedback and
no retransmission.
Okay, but if you share several flows between them, how does it deal?
I'm sorry?
If you share multiple flows, because it's just one flows here.
Oh, okay. Actually, we have that implementation. So each one of them, in our current implementation, each one of them has a different flow.
Okay, so it's you use a congestion control, something like that inside your UDP, or how do you manage between flows when you hit, for instance, a base station and you got dozen and dozen flows arriving at the base station?
Okay, we don't have thousands of flows at this point. We have, let's, for example, in the smart lamppost application, for example, there are devices on each lamppost, and each one of them is connected back to the lamppost on the left-hand side in the picture. Yeah.
Okay, and just a last question. So if I well understand, it's a protocol itself, like Quick, for instance, with a fake coding inside. This is not something that is added to a UDP flow.
Okay, actually, I think we'll talk about this offline, because I'm not the person doing the implementation. If possible, I'll relay your question to my technical team.
Okay,
Yeah.
but really interesting. Thank
Okay,
you.
thank you very much.
Okay, other comments, other questions? Thank you. I would like to talk just a little bit about the internet draft. So in the same way we asked for having something from the RLMC and Tetris people, we have now something for bats. That's also something that is, well, this is a solution that is currently deployed, so that's great. And so the question is, what's the future for this document? What do you, as a contributor, would like to do, achieve with this document?
Well, we hope that at some point it could be considered as part of a standard. Yeah.
Yeah. So as we said before, as we said in introduction, we are a research group, so there's no standard per se, but we can publish informational RFCs. That's feasible. That's one point.
Okay.
But it will not be considered as an IETF standard. That's not possible. But still, we can register that there was work being done. That's something that seems to be sound from the IETF point of view, and we have this document, this RFC with a number associated. That's feasible.
Hi, Dave Arana. I'm sorry for being lazy, but can you tell me off the top of the head what the IPR disclosures on that say in terms of rights?
I would just like to highlight the fact that Raymond has been very clear on this aspect since the beginning. So since the beginning, we know that there are IPR with bats.
So basically, there are three inventions, and for one of the
I
inventions,
just want, can you tell me what the IPR disclosure you put in on these was?
the contents.
Is it FRAND? Is it RAND? Is it nothing? I'll go.
Yeah.
If you can't answer off the top, I'll just go look it up myself. I'm just being lazy.
Okay, one of them actually is the most important one is the original invention of bats, and that one we have coverage in the U.S. and some European countries and also in China. And there's one which has some.
That wasn't my question. I understand you have patent IPR coverage. I'm asking, what does the disclosure to the IETF, IRTF say about what people's rights are when they use it for IETF and IRTF work?
What is the license? Is it a fair round, F round, or things like that?
The licensing.
Yes, the licensing conditions.
Colin Perkins, I guess the important question is, has there been an IPR disclosure made to the IETF for this?
We wouldn't be allowed to
I
talk about it.
think so.
And if so, you know, we can go look it up.
Yeah, we'll go look it up. I was just being lazy.
Yeah. If there hasn't been an IPR disclosure made, then you need to make an IPR disclosure.
Sure,
and
of
not
course.
just list it on the slides.
Okay, yeah. Thank you.
What? There's no other questions. That's fine. Next. Okay. So yeah, that's what the question was. Okay. So sorry. I think can people in the room raise their hands, or actually, no, we're not supposed to ask you to raise your hands because supposedly we want this to be very, that is the hum thing. I hate it, actually. I never understood it, but that's fine. Okay, so let's put it this way. Would anybody in the room object of this becoming one of the research group documents? And if you do, yes? If you do, say it, whatever. If not, we could actually also send this to the list and ask if anybody on the list objects to it, because I think this is, again, when I said that we had as a research group goal to have a list of existing codes out there so that people would know, because this is what all the time people ask us, you know, what's a network code? Second one is, where are they and which ones can we use? So if nobody has a major objection, I think that would be a very good document to become the research group document. So okay, Colin and Dave.
Small point. It's currently classified as informational.
Okay.
And that may not be appropriate for something that actually defines bits.
Okay.
It may be better classified as experimental.
Good idea. Good idea. Yes. Okay. Colin.
Hi, Colin Perkins. So I think Dave probably makes a good point, although I haven't read the draft, so I would have to defer to that. Other than that, provided the appropriate IPR disclosures have been made.
Yes, absolutely. Yes.
I don't think we can accept this as a research group document unless the disclosures have been made.
Yeah. Well, I think I had that in the back of my mind that, printing every legal T's and I's. Let's look
Yes,
at that.
I'm sure you did. I just wanted to make it clear, given we had some discussion.
Okay, appreciate your input.
Okay, so we'll take it to the list and we'll say that we'll ask the community. But I would say I don't see, again, like what Colin said, once we've done all the, make sure that all the patent disclosures have been made, I see this would be a very good contribution to the group. So thank you very much.
Thank you very much.
C'est toi, là. Et tu t'es donné combien de temps?
5 minutes d'avance.
10 minutes? 15? Ok. Okay, so next is Vincent without his chair hat.
Yes, so this is a follow-up on our RLC FX scheme for Quick. So just to remind you, we are considering here in this group, because this is more appropriate for the moment, some work on Quick, on adding possible FEC schemes in Quick. It's absolutely impossible to push this work at IETF Quick Working Group for the moment, but still it makes sense to have this discussion and to do that kind of work and also evaluate all of this inside this research group. So this is why we propose this. So we have two documents. One of them is coding for Quick. This is the general framework. How can we add coding inside Quick? And there is also another document, which is this one, how to do that for RLC codes themselves. So in this document that we just updated recently, we explain how we can do that in Quick using our RLC codes. So the specific details. This document is now in line with the other document. That was not the case until recently. So that's the motivation for doing this update. So it is in line with the Coding for Quick version I presented at previous IETF. Just to remind you very briefly, we want to do cross-packet frames protection. So it means that we consider a packet and we protect the whole stuff in the packet, perhaps with a few exceptions, because some of the frames are maybe less important, but that's a detail. So let's say that we want to protect the packet as a whole, all the frames of the packet, as opposed to protecting one stream inside Quick session. The great benefit of doing that is that we are frame agnostic, so we can protect whatever type of frame is defined in Quick. So that's the main advantage. In this RLC FX scheme, we leverage, of course, on those two RFCs I already mentioned, RFC 8681 and 8682. So that's great because it makes the document quite small and easy to read. We only focus in this document on the mapping and the signaling aspects, and whatever concerns the code itself is already defined elsewhere. So that's now very easy to do RLC FX schemes. That was also one of the expected benefits of having this prior work. That's just one example of FX scheme. We may add, and if there is coding inside Quick, we probably will add ourselves or somebody else, it's not a matter. We will add additional internet drafts specifying additional FX schemes for Quick when it makes sense. They don't work in the same way. They don't have exactly the same use cases. And it would make sense, for instance, to consider RLC schemes when you have real-time constraints and small windows, encoding windows, let's say, because it's a situation where those codes are working very well. And perhaps when you have a very high bandwidth delay product flow with a lot of packets to protect together, maybe block codes are a good approach for protecting them because there's less processing overhead, perhaps. So there's no clear boundaries. This is something we need to experiment. It really depends on the exact conditions, working conditions for each use case. But just want to say that there won't be a single solution, most probably. So I don't want to go too much into the details because I already introduced at previous IETF some of those details. So this slide is just to remind you that there is necessarily a mapping, and that's perhaps one of the key aspects inside this document. There is a mapping between quick packets and source symbols. So source symbols is the stuff, the piece of data that will be managed, the data chunks that will be managed inside the FEC encoder, inside the FEC decoder. So that's essential. But otherwise, quick packets will be sent as they were, with just one additional frame I will just mention after that. So there is a mapping between those quick packets and source symbols. It's a bit complex, so this diagram explains more or less how it works. So we perhaps add some padding, but because of quick specificities, we don't add padding at the end, but in the beginning, just after the header. We also cut them into fixed size source symbols. So the first source symbol will be a little bit shorter because with more overhead, we'll add some additional information at the beginning of these source symbols. The other ones will be a bit shorter, a bit larger. So they are not all exactly the same size, but either E-5 or E-1 bytes, where E is a symbol size. So unless there are questions, I don't want to go into those details. I mentioned them last time. Otherwise, so now we need to transmit quick packets. So quick packets will be sent as they are, with just one exception. We had one more frame in those packets. So this is the source FPI, fake payload information. That's in that case a very simple piece of information. Is just source symbol identifier, which is in this version of the document. We suggest to use a variable integer, but we may decide something else. It's not very important. So, but I mean that each symbol will be identified very precisely with an identifier. Otherwise, quick packet, repair packets that have been produced by the encoder will be transmitted. We propose to transmit them as another type of frame that we call repair frames. So there can be one or more repair symbols per repair frames. We can adapt depending on the maximum payload we can have. Well, depending on the path MTU and the symbol size. So we need to put more information in that case because we have to explain how this or those repair symbols have been produced. So we need to specify what was the encoding window at this encoder at that time. So this is why we identify the first source symbol inside this encoding window. We also need to specify how many symbols were in this encoding window. We also need to specify an additional parameter, DT. I won't explain what it is. And we also need to specify how many repair symbols have been produced and put in this repair frame because it needs to be self-sufficient. By processing this, either you need to identify exactly what is the size of this frame. So that's the reason for this number of repair symbols, NRS. Basically, that's the format of this repair frame. And of course, after this header, you will find all the repair symbols. There can be one, there can be more than one, depends on the value for E and the maximum payload size you can have in those quick packets. So the situation is the following. We have reference implementation, the reference implementation from François. Michel, which is open source. So you can download it and test it. There are a few open questions. It's far from being finished, of course. Some of them were also mentioned at previous IETF. I have 2 more open questions. Those are design things. I don't think it's so important to detail them at the moment. But we are making progress. That's the good point. So it's not finished, but we already have something that's perhaps that starts to be a bit sound, I would say. We start to be confident in what we are doing. We have this working implementation. We can recover from packet losses. We can adapt to several situations. So we, well, especially François, but also Isabelle, Emmanuel, and a few other people are working on this topic, and we're making progress. We're also making tests, and so there will be additional presentation of the performance results we can expect from those from this potential evolution of Quick in the future IETF meetings. So we are working not only on the specification, but also on the research aspects. So that's all. I'm done. I don't know if there are questions or comments from the room or from Nicteco. No? Everybody's happy? So that's nice. Thank you. Yes.
Karsten, could you go?
Can you repeat my question, please?
Yeah, I can.
Thank you. Can you just give some intuition about your choice of E?
About?
Your choice of E?
Okay, so the question from Karsten is about the value for E. So I think, yes, I have an additional slide. This is one slide I mentioned last time. So the E value is the symbol size value. So it's something which is important because in practice, you may choose any value between a few bytes and a few hundreds or thousands of bytes, it depends. That's one of the key parameters, and there is no single answer. It really depends on the use case, the target use case. But there are advantages in using small E values, or symbol size values. If you have largely variable symbol quick packet sizes, having a small E values will enable you to adjust very efficiently to those variable sizes efficiently. You won't be obliged to produce very, very large repair symbols if all the incoming source packets are very small. It would be sub-efficient, but okay, having a small E value in that case is interesting, is a good choice. But at the other end, if you use something which is too small, then you will end up with a large number of source symbols with large linear systems, which means that you will have more processing overhead at the encoder, at the decoder. So there is also, well, there is a balance to find between all of them. I don't have any magic value. That's a parameter. We need to well, test and find a good balance. It will probably be use case dependent. I don't know if, well, I don't have any answer, but those are the things that will have to be considered. You're welcome. Emmanuel, question, comment?
Maybe, but shame on me, I didn't read your draft.
Okay, no, okay.
So I would prefer to read it before asking question. So what I understand here is you're piggybacking.
So for people on the Meteco, this is Emmanuel Lechin from Toulouse.
I thought I said, sorry. You are piggybacking at the end of the packet, the redundancy, the repair information with he, or you are using a specific signal packet?
Yes. So this E value, as well as some a few more information, need to be exchanged during the beginning of the session.
Negotiation phase.
This is yes, let's say negotiation phase. It's not anywhere in the repair frame header.
Yeah.
It's something that is managed elsewhere in the session during the initial negotiation.
Okay.
We need to keep those, the encoder and decoder synchronized, and that's part of the information that is required for doing this synchronization.
So you got source data packet, and you got source data packet that embeds a part of repair packet, or you have full repair packet.
No. We have either original quick packets containing source data plus this FPI frame, because we need to provide this additional information in order to keep both ends synchronized. So that's one possibility. But basically, those quick packets are not modified, except that we had this FPI frame, or we have repair packets. And in that case, those quick packets contain those repair frames.
Okay.
That can be one or more than one, but I guess that well, it's not totally clear.
But all are quick packet. I mean, they are managed by the congestion control.
Yes. It should.
So okay. So the part of the repair packet is counted inside the.
The way I understand, yes.
Okay.
François will be able to answer more precisely.
Okay.
But the way I understand it, yes.
No, but I have to read the draft.
The other one should answer this question.
Okay.
I will. Quick.
I will.
Not this one.
Keep an eye on.
Okay.
I have two questions. Do you plan to write a quick?
Emile
I am
Stéphane.
Emile from Orange.
Yeah.
Oh, sorry to. But do you plan to write an extension of Quick for that?
Our ambition is to convince everybody that it's useful. We are doing that inside this research group.
Okay.
And then when the V1 will be done, and when it will be time to propose additional things, to go to Quick and see what's feasible from this point of view.
And I see.
I have another also. The same team in Louvain, they have an architecture that's called pluggable Quick to allow extending Quick without changing the basic protocols and the basic mechanisms. And we feel that that could be a really good example or use case for the pluggable the pluggable Quick. So and they had a paper in SIGCOM this year. So this is actually could be one way of doing this without again touching too much the current implementations when they get to V1.
Yeah, and when I'm saying that François is compliant with this implementation, I refer to this specific implementation, to this pluggable Quick implementation. So this is,
what is specific? Why is this specific to Quick?
The signaling part is specific to Quick.
The what?
Signaling aspects, mapping and signaling. This is specific to Quick.
All the setup.
I'm doing that in the different way for fake frame, for instance, because there are.
But why don't you use that for UDP? It should be more general. Just to speak about fake.
But Quick is not UDP. It uses the Quick is not exact. Quick is not UDP. It just uses.
I know.
It's
This is the question.
UDP. Yeah.
But if you consider fake frame, that's a way to plug, to do efficient coding between RTP, for instance, and UDP. It's a standardized way for doing that. Exactly.
If you are making chunk, you can make chunk of a UDP packet.
Yeah.
Just my feedback.
No, there are several potential use cases, and at the end, and I see that Carsten is waiting for asking a question or doing a comment. Loops is also potentially one way to use FEC coding.
So the sketches we have on our napkins, Carsten Bormann, actually look very similar to yours, but of course all the reference information, the numbers that point back and forth, they look different. So we don't have a quick packet sequence number, we have a loose packet sequence
Yeah,
number.
yeah.
All that.
That's the main benefit of having a specification of the code of the codes part, where all those mathematical and more complex aspects are specified, and then you just design fake schemes so that explain what is additionally required to use those codes in this context with those protocols. And there are, of course, usually several ways to do that, not a single fake scheme per fake code, given the target use case. But we have this flexibility, and that's a good way to proceed to push and use FCE codes where it makes sense. Emmanuel?
Yes, Emmanuel Rochin again. Just to complete, I think adding fake to quick is completely different from adding fake to standard UDP. So we cannot mix both together. And just a little bit of advertisement, you can use Tetris if you want to plug a UDP, for instance. But I have another question about the packet format. Just the repair symbol you got here, is it optional? Or if I don't use, for instance, inside quick redundancy packet?
There will be no repair frame.
There is no repair frame? Yes, so this is a specific header to repair frame.
Yes. This repair frame is not only the header, that's the first part is the one that I mentioned here is the header, but you can see that in green there's this repair symbol or repair symbols. It depends on how many symbols you need to transmit.
Okay, so just
can be more than one.
I just wanted to know whether I based some payload if I'm not using repair symbol.
How you what?
My payload, for instance, if my header stay as longer as this size, whether I use or not repair symbol. This is not the same header. That's what I said. For instance, I got an header and we got optional fields, and if I don't use it, they are still inside the header. Yeah. Okay, this is the case here or not?
No. If you don't have any repair symbol, there will be no repair packet.
There is no repair
frame,
packet, and I have my payload is unchanged.
Yeah. It's unchanged. If you're not using FEC, there will be no source FPI frame.
That's perfect.
And if the receiver, well, it should not happen, but if ever this is, if ever the receiver does not understand FEC, and if he receive this type of frame that can ignore this frame very easily, it's independent from the rest.
Okay, and is it expected
because there is some negotiation, but
is it expected to work full duplex on half duplex? It's possible to do half duplex, for instance.
I don't see any reason to prevent it from working full duplex, but
and half duplex, for instance, you just one path is protected and not the other one. Okay.
Emil, we'll go fast because we're going all the time.
Just to explain, Emil again, just to explain my initial question. Do you need to have the session key to do that or not?
Session key, all this happens before encryption. Does it answer your question?
This happen before encryption?
Yeah.
Okay, good.
Yeah.
Okay, good.
Yeah, this happens before encryption. Next. So the next presentation is about coding congestion control. So today I think we're addressing things that we had for a long time on our list, and there was no real contribution. So we're very happy about this contribution now, as it is absolutely a question. Every time you add coding anywhere, the first question that people ask you is, how does it interact with congestion control?
Thank you for the nice introduction. We were lucky to have François Michel coming to Toulouse to do some tests on satellites. And François didn't really like the way in research you have people comparing coding mechanisms that ignore congestion with coding mechanisms that do congestion. So basically, it's always an unfair comparison. People do coding and show, oh, look, my coding mechanism is great. Sure, you are just ignoring losses. So because he was slightly pissed off with that, we decided to start a draft to explain what we think on best current practice, even if it's not the place of an IETF group to speak about best current practice, but at least a base on which we can discuss, and can we put must or not, even if it's a research group, that. So if we look at RFC 5681, TCP is a loss-based congestion control. We know that BBR around that ignore losses, but that's another topic. Coding mechanisms could hide congestion losses to the sender, so there's congestion that the sender doesn't see. But however, we could use coding when we have tail losses, or when we are in a case where we have lots of non-congestion losses that would be interested to ignore that when we repair these losses. So that we tried to provide some best current practice or some best practice without the actual BCP on how coding and congestion control could coexist. So just a disclaimer, because we wrote that without the tunneling in mind. So just something we wanted, because we are worried on quick ignoring losses in our satellite use case. So that was really applied end to end. So that's what we started like that. Maybe it can be applied to tunnels, but that's not the initial discussion. What we propose is simple, because even between the authors, we didn't agree with the solution. So, but you need to have a base solution, and if you have a draft where you only say, you may do that, you just end up saying nothing. So we decided you need to say things. So we said the receiver must indicate to the sender that one or multiple packets have been recovered using a scheme. So then how he does so depends on the congestion control mechanism that he's using. For example, you could use ECN signals if you are using TCP. You could use a new type of signals such as the recovered frame in Nwcrg. So it depends on how you are doing things, but the receiver must indicate, because we think the decision is at the sender, because he knows more about the situation in the network. He knows more things than the client only. So the server must be able to detect the signal. Those are the base idea. We do not describe how we must react, but then we just drive a list of possibilities. Because on the sender side, when you do coding, you could just ignore the congestion window progression. You could just decide that whatever I do, I just add 10 packets, or whatever I do, I just add a coding rate to every packet. I could do whatever I want. I just ignore the congestion window progression. That's something you could do. That's something that some people in research papers do.
Michael Weissel, nitpicking. If I consider the previous slide again, I was thinking about this statement of the receiver must indicate to the sender that one or more multiple packets have been recovered. So the point here is that the sender learns about loss, right? But so that is one thing which is okay to do. But do you really want to always convey all cases where you were able to recover? What if you're not able to recover something?
Then
it's an unreliable data transfer where you don't need to retransmit it, then you may not need to convey that, yet you still want to inform the sender about the packet loss, right?
But you still inform that the packets have been lost because you don't acknowledge them. And when you just, then if it is an unreliable transfer, the server knows about it. He knows it's an unreliable transfer, so he would just ignore that the packet has been lost and go on sending new packets. That's more the smart things are at the sender, because he knows what the application.
Sure. No, I agree with that, but I'm thinking that there is a corner case here that may require a bit too much actually. So there can be a case where I send 10 packets, and 5 of them are lost, and 2 of them are recovered. Right? Then if it's an unreliable data transfer where I don't need to retransmit everything, I care about knowing about the 5, but I may not care about the 2.
Okay, yeah,
that's what I'm saying.
Okay, I think it's true that, but then it depends on what signals you use to notify what has been lost and what hasn't been lost, and then how you actually do it. That because you could stack and say, okay, these papers, these packets have been recovered, these one have been lost, these one are on my side. You could, if you're using a new type of frame in Quick, you could actually do that. Really, that's why, for the moment, it's just basic statements on who knows what and who indicates what to who. Where. Yeah, that's it.
Last moment, quick comment. Recovered doesn't mean lost. You might actually work on a recovered packet because the lost packet, the apparently lost packet, has just been delayed.
Yeah, yeah. Can be, you can have networks with reordering, layer 2 reordering, and you actually recover a packet that you acknowledge just right after. That's something that indeed we have discussed with Emmanuel recently, and we were thinking that there's also an impact on the delay acknowledgements, because we don't act every packet. You may have a delay that could cover this kind of effects. I think that's something we need to have. If we go further with the document, that's the end of the presentation. Do we go further? And we are happy to have more authors and more people. And just, if we go further, this is the kind of things we need to at least put warnings on.
Hi, Dave Oran. So this is fine, but I think you're missing the inverse case, which is you aren't losing very many packets or even any, but you don't know how many extra coded packets you sent that the receiver actually didn't need to recover the data packets. And if you knew that, you could actually figure out whether the right thing to do is to increase your congestion window or reduce your coding rate when you have adaptive coding rates.
Indeed.
So I'd encourage you to also look at the success the success cases where you've decoded something with 2 repair packets, right? But you actually wound up receiving 5 repair packets because the sender was sending 5. So it gives you an extra degree of freedom to play with whether you want to increase your congestion window or decrease your coding rate.
Yes, you're right. Point taken. I think we need to add some things about that in the document. And thank you, because I think it's useful if we want to go further with that, to gather all these issues. If you want to go with us on the draft, you're welcome. Just there's all these kind of corner cases. We need to think, if we want to have a good document on the interactions between these two things, we need to have people that know a lot about coding and congestion control to actually come together. Because it's always, at least to try to have some, because what you mentioned now is related to how you actually consider coding within your congestion window or not, because you could just add symbol.
So Dave, just a truth in advertising thing. You're only addressing window-based congestion control schemes. So you wouldn't. This does not work for. This is not what you do for a rate-based scheme, for example.
That it's the same. If is BBR BBR is the rate-based congestion control. We are in the cases where we have a congestion control, whether it's Windows-based or not. That's
so. This is described in terms of a window-based congestion control scheme, right?
Okay. Okay. We try to be the more general the possible, but if
right.
if
and then there are corner cases like relentless, which I'm not necessarily saying you need to describe relentless, but it wouldn't work this way if you did relentless.
It's true that we have started the draft with quick issues in mind, so that's maybe why we are.
Spencer Dawkins, I wanted to just thank you for starting this work. And if I'm understanding this correctly, you're at -00 of a base solution, and you're already getting an awful lot of interest. I think that's a really good sign for a research group. So thank you especially for bringing it. I hope this all works out, because I know that there are people who need it.
Thank you very much.
Yeah, and I would say we're all very, very happy, because we've been wanting to have that work like almost since we started this group. So it's really good stuff.
Because I know I have lots of slides on which we can disagree. And that's also why we wanted to have statements, very strong statements from the beginning, because you interest people if you have strong statements. If you just say, we may do that, nobody cares. And to have a feeling on who is interested and to come with us on that document. So on the Thunder side, basically this presentation, there are, in the document, there are two things. Thunder side coding solutions. And then, I don't remember. And then what do you do? Because everything is on the Thunder. Whatever happens, I know that the clients, then there might be issues because we don't report the good things, but at least when we recover a packet, we report it. And then what the first part of the presentation is how the Thunder adds coding, and the second part is what do you do when you receive recovered packet information. So there are two parts. The first part is you could just ignore the congestion window and add a repair window that could be based on another congestion control. You could use let-bat, for example, to try to have somehow lower than best effort. There are many solutions here. You could just have your congestion window and data window that are the same, and you just add packets. You ignore congestion. The other solution is you have your congestion window, and within that, you include your repair packets. And that is when your point, Dave, is important, is whether there are the link between the data rates and the actual data I'm sending. So that is where there are two, maybe there are other solutions, but one way of seeing the things. For the sender side reactions, we could say when I receive a recovered packet, I consider that as the lost packet. So I have the same type of reaction that I do when I lose a packet. That's a solution. But when you are considering anything like your LAMP was saying, when you have huge losses, you don't want to have this kind of behavior, because what the hell you need coding if you're just behaving as if the packet was lost. You just maybe save some RTTs, but it's not really relevant. Another solution is doing somehow what you have in your RFC 8511, saying, I just have my congestion window when there's the loss, and when that's a repair packet, I just diminish it, but with a lower level. That's because basically for the moment we just have three solutions. I just consider the packet is lost. I do the same thing that for a lot of packets. I do nothing. That's what lots of research papers do. I ignore losses and go on increasing my congestion window as if there was no loss. And this is somehow maybe a trade-off that would be interesting on, I don't ignore the losses, but I still reduce in case there was actual congestion. You don't like it.
Okay. Yeah, I don't understand the intuition between reducing by less just because you were able to recover. I don't think it makes sense. And I don't make, for the record, I also don't think it makes sense to keep on increasing, right? I think we agree on this one, but I don't think that there's a point to make a trade-off between something stupid and something reasonable by saying something half reasonable. There's like, that's not better.
But well, there has to be something in between, because speaking, because this is basically why do you need coding if you just react as losses, and why do you just ignore congestion if you just ignore it? If you have a coding that recover every 2% of losses, and if you have 2% of packets that are lost because of congestion, you're just ignoring this congestion. So there's something at least that we must discuss as a group on when we speak about, I think that is where we have the discussion on interactions between coding and congestion control. This is the kind of things that we need to find some consensus, I think.
You guys good? So Spencer Dawkins again. I just wanted to mention one other thing here. Yeah, the thing where we spent, I don't know how much time, but maybe 4,000 or 5,000 RFC numbers amount of time trying to decide that ECN signals weren't just the same, the same as loss and going to be treated as loss, and that we wanted to do scalable congestion control. The stuff where it's like now we want to do ECT1, and getting that through the community and into RFCs was a hugely big deal. So I would ask you, you might want to think about kind of, do you want to shoot for it's the same as loss, which is the ECT zero view of the world, or do I just want to live in an ECT1 world, where I can tell people to speed up a little bit and slow down a little bit, and that might tell you things also about how much coding you're doing or not doing. And I think that, not to step on Karsten's toes, but that's something that would be extremely helpful for the many kinds of proposals that are like loops. It's like, we know something happened and we don't, we want to do the right thing and we don't know what that is. So with back versus retransmission versus, I don't know what, so I think that I encourage you to include the scalable congestion control ideas in your work when you get past 0.0 and get past the base solution.
Thank you.
A good point, definitely. In fact, what we want to highlight here is there is an antagonism by using both congestion control and erasure coding at the transport level. And it will be the case for every kind of protocol, whatever it is TCP or QUIC, we will get the exact case. Because you got one is going to grow up because there are more and more laces, if it's adaptative, as said by Dave, and you will get a congestion control, but it's going to decrease. So there is a problem. And you won't get a good result anyway. So the fact is how we manage that. Is the network is going to manage the redundancy and to drop it. If it's too much redundancy inside the network, treat it as a best effort traffic using some scheduling mechanisms like diffserv, I don't know. Or how we are going to manage both. Maybe it's not at the TCP level or at the transport level we have to do that. Maybe it should be stick at the IP or low level, link layer level. This is all the questions we want to point out here, because we cannot manage to plug transport level and congestion control and erasure coding team easily.
And may I add something? As I understand it, the goal of this document is not to solve all the problems. The goal is to highlight that there is, as Emmanuel said, an antagonism, and that there are a bunch of proposals, I won't say solutions, but proposals, and we need to discuss them. The goal is to make it, to bring some light in this domain. That's the way I understand it.
Casper, we're talking about goals. Why do you want to do congestion control? I think the obvious answer is to protect the network. But there's also always the question, do you want to have TCP fairness? And I think you have to be very explicit about what your objective is. Do you just want to protect the network, or do you actually want to be fair to TCP?
Okay, so I'm not the type of guy that hide my objectives. My objective is to have quick working on satellite links. And I see that we have issues in our networks where we have losses. So I think maybe having people to think together on whether we can include FEC in quick is relevant. And I know that when one of the wall that we will have when for quick v3, we will have FEC in quick. There will be, but how do you manage the interactions between FEC and congestion control? We will have this discussion happen if we end up having FEC in quick. So that's my main, that's why I said we're not focusing on tunnels, we are on end-to-end networks with losses where we have to manage some congestion. And so I want with this document to prepare at least a base on which we may agree on advantages or disadvantages when we will have the walls of deploying this kind of solution for quick. Otherwise, FEC in quick will not happen because lots of people don't like it. And people would say, how do you manage it? Because congestion control is complicated and so on. So if we end up with some simple solutions, we may end up having that deployed.
Yeah.
That's my main objective.
Okay, I add a third potential objective here, getting by the ISG. But really, I think you have to say whether you want to be TCP fair or not.
Okay, so we may want to put that in the document that because this is something that we have added on the slides, that it is not for the tunnels. We have to insist on the slide that it is for end-to-end, where we need to have some sort of TCP fairness. Even if they have a huge paper of Bob Briscoe on TCP fairness chain saying it's useless, but that's a very nice paper if you have time on your plane. Back.
So this is an RG, and one of the goals of an RG is to figure out what research we need to do. I was looking at the document, and it starts to talk about what the possibilities are for how we marry congestion control and coding. It would be really nice if we put some thought in as to how to guide research, say what things do we need to do research on in order to actually decide what the right path is, right? As opposed to just sort of say, here's a couple of ideas, have fun.
Okay.
I'd encourage a lot of people in the room who are interested in either no coding or congestion control or both together to sort of help give some guidance and sort of point people in the right direction, because we could spend a lot of time doing useless simulations and research that doesn't actually inform the final solution.
Yes.
I think in sake of time, this sketch could be going on forever. In the sake of time, we would like to cut the line. But again, for those of you who've been involved with us for quite a long time, congestion control and the interaction with coding was one of the original research group items that we had. Actually, Vincent and I had actually defined a few years ago. So I would suggest that we bring it back, that we make it a major focus of this research group, because it needs research, obviously, and then put it obviously on the list for discussion at the next meeting, and actually really go sorting through this. I think it is one of the major research, I would say, into the protocols. I think at the beginning we're doing a lot of coding as codes. I think now we're at the point where we need to start looking at the implications of coding and protocols, and this is a perfect idea for it. And if everybody agrees, we will bring back the research group work item, and actually make progress on this. And if somebody disagrees, please come to the microphone. And nobody disagrees. So, Nico, do you have more slides?
We already disagreed a lot, so I think we shouldn't skip that one.
Okay, so
just source of discussion.
We still have two very important presentations. So I think we'll close it now. And thank you very much for raising this. And again, merci Emmanuel also, because this is, again, for people who've been around, this is something that we always wanted to do. So thank you very much.
Thank you. And we confirm on the list, of course.
Okay, so this presentation, thank you, is about one common problem that we often study in this group, which is we have our coding system, so coder, decoder, the codec part, and it's need to exchange not only symbols coded and coded, decoded, but also it's need to exchange sometimes some states. And then the question is, what information do you need and what do you need to do? So it's a kind of, thank you. It's a kind of follow-up of a discussion by Vincent on the fake, generic fake API codec that has been presented and that is ongoing. And my presentation here is more about how can it be extended and what is needed. And it's just to start the discussion. There's no definite answer, of course, now. And it's linked also to the general problem that, of course, in many protocols, you need to exchange states. And some of it is related to your coding state. And this should be reflected back into the API. So I will take the example of implementation, the open source implementation that we took, which was made with Hackathon, which is a Swift codec, and it works that way. You have on the left side the sender, on the right side the receiver node. It's a systematic code.
So a source symbol are sent directly, and then the API divides the application with the encoder, and the application feeds the source symbol to the encoder, and from time to time it will ask for a repair packet, and how it does that is by specifying which source ID it wants in a linear combination, also implicitly what are the coefficients that it wants. So these are then the application asks for a repair. It is then obtained, send over Y, and the receiver node does the symmetric things, which is feed all the received packet inside the decoder. And then when it's a repair packet, specify exactly which are the source ID and which are the coefficient value, which is implicit but can't be explicit. And then the recovered source symbol are sent back. So as you can see, this is most of the current generic fake API. You can do a lot of things with it, but there is a question of you don't see a lot of state here exchange. So there is a question of, okay, if you want to do more general protocol, like if you have feedback, we have discussion about feedback, or if you want to do information-centric networking or random linear coding, RNC, and doing the recording part, or even if you want to do some multicast transport. So there was a discussion this week, for instance, on multicast in the LP1 group, where they want to do potentially a new kind of fake based on basis that they have very short packet doesn't bytes. If you want to do that, can you do that with the current API? And the thing is that if you look at current protocol implementation, they don't always do have a codec abstraction. So if you make a codec abstraction and want to look at the information flow, it will be a little bit like on this diagram. So the receiver state has to go from the codec to the application, and then it has to be sent over the wire if you have some kind of feedback. It can be a summary of a local state, of a local state of the codec. So it could be either the entire state or it will be a summary. And then the sender node would typically also get the local state of the encoder, and using both information, it could generate a coded symbol. So I think, okay, there's not much information here, but it's just describe the information flow, and everything is the detail of how you do step 1, 2, 3, 4. And if you ask the question, okay, how does it work when you do some complicated case? So I think there are two cases that are not so straightforward, so to say, which is information-centric networking and random linear coding. So like in any protocol, in those cases, what you do at the encoder is to select the indices of your symbol that you will generate. But you need also, as in many other protocols, you need to know what your peer needs, which is the decoding state that you received. But the subtlety is here is it's not, if you do recording, you don't have access to all the source symbol. So you need to have information about which symbol you could generate. And then you need to match both what your peer need and what you can generate. And this is not straightforward because you can end up having to solve the index coding problem if you didn't think, well, all the thing I had. So there is a kind of research and design issue here. Now, I don't have precise solution to extend the API on this subject, but if we look at what we will do in the current implementation, so of course the local state, as we do linear coding, can be represented as a matrix. So we could imagine to pass the matrix back to the application, but it's, of course, it's large. It works. It's not nice because then typically we'll have to do algebra in the application or protocol part. Maybe there are alternate representation. For instance, if you do a kind of LDPC peeling decoder and related to and send maybe a Tanner graph representation, I don't know. So there is this open question for the API, for the local state, and for the remote state summary. So here, okay, there are several things. So first of all, you could directly send your states. So maybe even the previous matrix, or you could request directly what you want. So if you send your state, of course, the other side will know what you need. Then you could also implicitly state what you have by doing acknowledgement. Then if a source know what the receiver has lost and what it has received, it can deduce at least a pessimistic bound of what the receiver has. And then if you want an explicit summary, so you can send the matrix, or you can do some kind of compression of the information in your matrix. For instance, up to where you have decoded, or you can also specify, for instance, on the symbol ID level, which ID you want, you don't want, you are interested in immediately or in the future, or you can send something related to the people. So here there is also for the API the question of what is a good representation of a remote state. And then we can look quickly at some existing protocol, which is more on the remote state level. So, for instance, for netcodings or CCN and NDN draft, they are mention of feedback, int, and also how to transmit this information. In Dragoncast and Dragonet, the information that you use on protocol level is the last symbol decoded, and then rank and highest symbol ID. So it's the fake API is almost there. For Tetris, I think, and people can confirm, it's something which is equivalent to the pivot of the matrix, and there are many other possibilities. So anyway, so there are a lot of open issues, as you see. We, as author, we plan to do the following: start from particle case, try to fit in the API, and then try to do some suggestion, and we'll start with implementation of Dragonet. And then there is a question of, are there more general cases of state exchange that can be factored between different protocols, and that should be reflected in the API. And of course, we welcome advice, comment, contribution, discussion, either here or in the mailing list. Yeah.
Thank you. Any questions? Okay, well, thank you so very much.
Just a comment. Oh, yes, this is Vincent. Good point. We need to see what should be done in terms of API to reflect this need that some of the protocols using those FC codes may have. Yeah. But let's keep it simple, and I would say today, but we have to talk about it a bit more. Let's do things more specific. Let's leave them as implementation specific features in the API. Yeah, there is this generic get fake parameters that does not require you to specify exactly how to do that. That can be used in an implementation specific way. So we will talk about it, but it's good to point this requirement.
Okay, thank you.
So I suggest we skip the last item from Marie-Jo.
Yeah,
and now we have a
okay,
bit more.
So now we have more time for you, Karsten. And this is actually the view from the IETF. I think at the IRTF Open, we talked a lot about collaborations between the IETF and the IRTF and how to, move things from one place to another, or how to use technology or the research that was developed here and the technology that was developed in the IETF, and make sure that they match better together. So thank you, Karsten, for doing this.
Okay, thank you. Do we have any clock here? I'm big enough, they will get me anyway. Yeah, I want to give a quick introduction into what loops is. Who has been at a previous loops site meeting? About half of the people here in this room. Okay, so I will have to speed up considerably, and you may need to stop me if you are missing some context. Yeah, so we're in the network coding research group, so I think we all agree that packet loss is something we want to avoid, in particular tail loss. And Loops has a completely different approach from the things that you have seen here so far. We want to do something in the network. So the hosts are completely oblivious to what's going on. The hosts are sending probably encrypted stuff that we don't understand. We have no idea what transport protocol they are speaking. All we are seeing is IP packets. And we want to be able to recover IP packets that get lost within one segment of the path. And well, this can be done locally. Doing things locally always is good because we can do this fast with low latency. And we also don't have to send recovery packets end to end and spend the bandwidth everywhere. We can do this in the network, so we don't have to upgrade hosts to do this. And yeah, the new thing here is the assumption is we are not going to look into the packets, we are not going to touch the packets, and of course, traditionally, performance enhancing proxies have done all of this very much. So there will be two ways of doing recovery. One is, of course, the traditional retransmission, and the other one is forward error correction. And what the protocol then essentially does is it encapsulates the forward error correction, but it also sends back information to the coding side to possibly dynamically adjust the parameters. One approach here is that given this is in the network, we assume there is some management. So we are not going to define that part of the protocol that does setup for these path segments. We have a controller model here. Maybe there will be a Yang module at some point that contains all this, but this is kind of out of scope. Yeah, I think we have talked about congestion control. And given that we are a tunnel, we have to export congestion control information out of the tunnel, of course, preferably with ECN and possibly with selective dropping. Now, this is, of course, confusing. We're trying to recover packets and then we are dropping some. Of course, this means we are just recovering a few packets less than we could. And the assumption is that there are modes of doing this where the recovery still is a net win. But that's not what I want to talk about today. But really, Loops is a protocol that feels a lot like a transport protocol, but isn't. First of all, it's completely separate from the end-to-end transport protocol. We are not meddling with that. But of course, we are providing information. We are sending congestion feedback. So the idea is that Loops itself is not controlling the sending rate. Maybe it's doing some pacing, but the sending rate really is under control of the end-to-end transport protocols. And the other thing is residual loss is okay. This is an unreliable protocol. And yeah, we also can maybe get more information extracted from the path segment that your traditional transport protocol could, because the tunnel is carrying aggregated traffic. So a lot of the intuitions we have for transport protocols really need to be re-examined. They may not be entirely true. We have a controlled environment, we have a setup mechanism, we don't have full reliability. We can do things like set the maximum overhead volume from the outset. We're never going to send more than 10% overhead, and everything the protocol does stays within these 10%. And that, of course, has some interesting effects on how you look at congestion control, because you cannot really blow up the network with those 10%. So you might have a slightly different view at this. And finally, since this is a tunnel, we have multiple flows in there, and we usually have a lot of packets in flight at any particular point in time, so we might have much better measurement opportunities than a traditional transport protocol. There are a few strawman documents out there. There is a use case and problem statement a document by Ijo and Joe, where was Joe? There's Joe, right? There is a generic information set by Michael and me, and this is pretty much the protocol, but not yet bound to specific bits in a packet, because we want to do this specific to encapsulations, because different network environments have different preferred encapsulations. So this is a generic information set, and this is then bound to a specific encapsulation, like Genève or GUE or GRE, whatever makes the most sense. So these are documents that you can read, but of course they don't contain all the answers yet, because we are still looking for some answers. Dave.
Dave Rand, again, excuse me, I haven't read this stuff, but I had a real quick question. Because you said of all the things you didn't do, is one of the things you don't do reordering?
Well, the network does the reordering, and we might be doing resequencing. And that is actually indeed a question that comes up.
It is part of the requirement to take misordering that occurs inside the tunnel and fix it at the tunnel exit.
Part of the requirement probably is to be robust against reordering that occurs in the tunnel. Whether it should be fixed at the exit, that is a matter of debate. I don't think we have an answer to that yet.
Okay, thanks.
So I would like to avoid having to do it, but let's see where we get.
I have many opinions.
Yeah, it's not an easy question.
No, it's a very easy question. I agree. Make everything else robust against misordering.
Yes. That is the answer. Yes, that's and world hunger as well. Right. Yeah. Okay. Apart from the technical documents, there is also a proposed charter out there. So if you want to see more precisely what we propose the working group to do, you can look there. So obviously this is not happening in a vacuum, and in the BOF at the last IETF we identified many places we have to talk to. For instance, the transport area working group has been discussing congestion feedback, so we want to make use of that, and there's lots of other things, and there's of course in particular this research group which we plan to tap for all the information about erasure coding and recovery that we can get. And we also see that you have a lot of experience with encapsulation techniques. So one of the figures out of the FSC over quick document already made it into our slide rail. Yes.
So my question will be, this is Marie-Josée Montpetit, with or without chair, I don't know. The question I would have for you is, how can we help you, and how do you see, we talked at the IRTF Open of the mechanism. So how do you see the mechanisms for that type of collaboration going?
Well, my assumption is that we first of all look at products of the research group. For instance, these documents are being created. They actually already have moved to the IETF, but they come out of the research group, so it makes sense to talk to the research group about why they are the way they are, because we are not using them unchanged. We're using the general approach. So this is one part. And the other part is that based on the number of assumptions, we will have specific questions. So for instance, this lists 3 classes of FEC schemes that we might want to use. And this is a random guess. And I'm sure a lot of people in this room have a more refined opinion on which classes.
I would say I have strong opinions, but I'll let Emmanuel talk about it.
So the idea is that the working group will formulate questions like this and get help from the research group in answering these questions, or at least formulating hypotheses. And in some cases, the result may be a research question that actually you have to sit down and do a simulation, like my question about E a couple of minutes ago. We don't know what that number will be, and we will have to design some research to find out.
Definitely, I think there are many research issues here. When we deal with tunnels, so you get multiple flows and you treat the aggregate inside, for instance, one sliding window schemes or whatever schemes you are doing. And following the redundancy produced, you might have at the end of a tunnel some head-of-line blocking, because the protection is different between multiple flows. And you need a source repair packet to be able to decode. And maybe you don't have a good source repair packet for a given flow. So there are some scheduling needs, I think, at the entry of the tunnel if you want to be as performant as a single fake protected flow. So there are many things, and I did some tests with that, and I do not have the answer yet. But there are something to dig up here for sure, definitely.
So you're talking about the situation where we have different traffic classes and all put.
You got different traffic class, different size of flows, micro flow, micro flow, and maybe you got a fake encoding is encoding a part of 5 packets of one flow and 2 packets of another flow.
Yes.
And at the end, there is one missing packet for the shortest one, and you cannot decode, maybe, for instance, because you are still waiting for 1 packet of a given flow that built the repair packet. So you slow down some flows because you got a fake code which is produced by different kind of flows. And I already observed some head-of-line blocking because some flows are waiting for a source data packet from another flows to be able to decode the missing one.
Well, the trick here, of course, is to not even identify those flows.
Yeah.
And we're going to have a hard time identifying them because much of the information about them is actually encrypted.
Yeah. Sure. So maybe there are some schedulings we can do, maybe just only on the way a packet are on queue, keeping only the socket informations to. I don't know. Yeah. Honestly, I don't know.
So if you can send some more information about this set of line blocking to the list.
Yeah, sure. I have some curves I did with Pi, with FQCodel, with some other scheduling, trying to explore how we can deal with that. So, but
I think if you do that, you should copy both lists.
Sure. Okay.
Hi, Colin Perkins speaking very much without any hats on. I mean, you list a bunch of different FEC schemes there, and obviously they have very different characteristics.
Yes.
One of the things we found with doing the FEC for video and audio in AVT is that it was possible to build general purpose mechanisms that you started out with a very simple parity FEC scheme, and then we gradually added more and more things. And it worked okay with the simple scheme, and it worked perhaps better with the more complex schemes, but you could choose where in the spectrum you lived. Do you expect this to be the same sort of thing where there will be multiple FEC schemes which you can address different levels of protection with a different complexity, IPR, etc. trade-offs, or do you think there's something that needs a particular FEC scheme to make this work?
My hunch would be that we actually want to dynamically change between these classes. So if you just have a very low level of random losses, then a parity scheme may be fine for you. And when things start to become interesting, then probably you want to have a better scheme, and then you have a reason to expand the CPU that you can save by the simpler scheme.
It's Marie-José. I would have a follow-up question. I know you're not done, but because it's coming in, so do you intend to have some kind of signaling for that? Because
Yes.
when we did Quick, that's what we added, actually. We added some kind of signaling to decide which code we want to use.
And we did the same with the real-time media.
So yeah, so that's exactly the part of the protocol that needs to be designed. So what's in the forward information, and this is pretty much the index or the set of indexes you need, and a format for the repair packets. And in the reverse information, all that feedback information would come that is needed to make decisions of this kind.
Yes, and the feedback information presumably includes sort of lost, which packets were received, which were lost, which were repaired, and that sort of
Yeah, maybe which packets, or maybe just how many were and how many weren't. And you can even think about hybrid approaches where that feedback triggers some retransmissions if you still have time budget to make it useful for the application.
Okay, thank you.
Yeah, so I covered that, and there is a number of assumptions here, we have a pretty large variance of the size of the payload packets. I think this is similar to the quick work. This is probably why we arrive at similar ideas how to encapsulate things. Yeah, packets are divided up, and this is not necessarily related to the way they are sent forward. And then maybe we want to do some piggybacking schemes, so we don't actually get more packets, but we only get longer packets, and that may be an optimization that's actually useful. And on the other hand, we may want to split packets that are larger than the MTU. So that's very much open whether that makes sense or not. So this is exactly the kind of, we have seen this figure already once. Yeah, I'm pretty much done. Yeah, so the design choices we need help with is what are these classes of FEC schemes, assuming that we can define classes that need approximately the same kind of feedback information. So within the class, we can be algorithm agile, but when you go to a different class, you just need different feedback information and different index information. Ideas about mitigating the MTU problem would of course always be helpful. How do we make use of feedback, for instance, for controlling the FEC rate? What is a sensible timescale there, and how do we construct those packets? Let me just show one last slide. We haven't been chartered yet. What we had at the last IETF was a non-working group forming BOF. So we are talking to the ADs on getting the working group chartered, but that doesn't stop us from actually doing the technical work at the same time. And in particular, we want to explore the design space. Maybe we want to do the tough decisions only when we are actually a working group. But exploring the design space is very much what we want to do now. And we want to improve our set of documents, maybe adding a FAQ document at one point. And it would, of course, be interesting to see who is interested in doing the FEC work. There is a GitHub repository. There is a mailing list. Please join the mailing list. It's not going to kill you traffic-wise. If you are interested in this, and of course, if you have input to the charter proposal that is at GitHub, that also would be very much welcome. And the timeline for the whole thing is that we believe it should be possible to charter a working group in time for IETF 107. Let's see if we pull this off.
Thank you. Questions, comments, questions? Yeah, maybe we could become, you guys have T2T RG and you have core, and maybe we could be a bit of the same thing, like the kind of thing that goes from one to another.
Yes. Well, T2T RG is actually the partner to about 14 working groups at this point in time. That is the number.
No, but what I'm saying is the same type of relationship.
Yes,
You have one in the RG, you have one in the working group. So,
Right.
It could be something similar.
Yeah, so just an example, in T2T RG, we have designed a hypermedia format, and we like that. And at some point we decided, let's throw it over the wall to the working group, and that is now looking at standardizing.
Good. Yeah, it's good. Thank you very much, Carsten.
Yeah. Thank you. Yes. So we are done. Well, wow, 4 or 5 minutes late. Before splitting, I would like to say something. We are about to adopt several documents, and there is a requirement. If you want your documents to be reviewed by others, then it's very, very important that you yourself review documents of others. That's the way it must work. So please read and send comments, especially when we are doing last calls, but not only. So please read and review.
Well, I'm going to put Raymond on the line here, but I think it's not the only thing. Please review also the IPR, and if there is new IPR, if there's other IPR, please, please, please submit it, because if not, we cannot go forward. Thank you very much, and I guess we'll see you in Vancouver. And for those of you who are interested in computing in the network, I will do some advertisement. And please come, and if you're here tomorrow, please come to the other working group, the other research group that keeps me awake at night. And this one is really keeping me awake at night, computing network tomorrow morning at 10. Thank you very much. No, but I sent you the link. You just have to. You just have to link. It will take. It will take 10 minutes. Thank you for coming.
Parts of it.
That's great. So you saw my suggestion. Oh, the one from the sisters group. Oh, and you know, Kanchana, we're going to have a workshop on Friday. The sisters group was very lunch was very productive. Now we were a few of us are on the